Hi guys, my name is Jeremy, and we did our project on Bluetooth Low Energy and iBeacon. So Bluetooth Low Energy is also known as Bluetooth LE or Bluetooth Smart, and by the name it's obvious that it uses lower energy than the traditional Bluetooth. It's also supported by all the current versions of your major OSs, so Windows 8 for example, but not Windows 7. And it's going to be on 90% of Bluetooth-enabled smartphones by 2018. Bluetooth LE was originally developed at Nokia, and it was released to the public under the name Wybree in 2006. And then in 2010, which was when the Bluetooth 4.0 specification was released, the Bluetooth LE was added into the specification at that time. So it became sort of part of the official Bluetooth protocol. And then in 2011, the iPhone 4S came out, which was the first smartphone to implement the Bluetooth Low Energy. And here's a sort of comparison of the Bluetooth Low Energy versus some other different wireless protocols. And you can see the Bluetooth Low Energy is its purpose is to communicate state information, which is by state we mean low bandwidth, low latency data, and also by using it should also use like low power. And so in that sense, it's more similar to Zigbee and ANT than to traditional Bluetooth. So and its functionality doesn't overlap with the traditional Bluetooth, which is for voice, data, and audio. And so you can actually have both on the same system, and there's a good reason to have both. And here's a power comparison between the Bluetooth Low Energy and Zigbee and ANT that was done at the University of Washington. And so what they did was that they would send a small packet at n number of seconds, and then measure the current consumption. And so you can see that the Bluetooth Low Energy is actually a lot lower than the Zigbee and ANT, especially if you look at around 10 seconds, 10-second interval, the energy is about a quarter of the Zigbee and ANT, and it's lower than the Zigbee and ANT everywhere. And the Bluetooth Low Energy implementation is actually a lot simpler than the Zigbee and ANT, so you can have a cheaper device that actually can run it, so it's more cost effective in power and in actual dollars too. So the Bluetooth 4.0 is, I said earlier, where the Bluetooth LE was officially added. And so Bluetooth 4.0 has two different protocols. You have your Bluetooth BR, which is Bluetooth Basic Rate, or also known as the classic Bluetooth. And then you also have the Bluetooth Low Energy. And a Bluetooth 4.0 system can implement either one or both. And but the two aren't compatible. So if you have one system that only speaks Bluetooth BR and another system that only speaks Bluetooth LE, they can't communicate together. So that's why it might be good to have both on one system. And so here's some different logos on the right side, and they indicate like different functionalities. So if you have a Bluetooth Smart Ready logo, that means that you are compatible with both the Bluetooth BR and Bluetooth LE. And then just the normal Bluetooth logo just means Bluetooth BR, and then Bluetooth Smart means Bluetooth LE only. And here's some sort of technical specifications. And if you look at the latency, you'll see that the Bluetooth BR is about 100 milliseconds, and Bluetooth LE is 6 milliseconds. So the latency is a lot lower for the Bluetooth LE. And one of the main reasons is that the Bluetooth BR is connection oriented. So before it communicates the data, it actually has to set up a connection and things like that. So it takes a long time. Whereas on the Bluetooth LE, the connections are optional. So you have the flexibility of just being able to send data just straight on without setting up the connection. And so you can save a lot of power and have a lot less latency that way.
So this latency is when you are using the optional connected thing, or
yes, yes.
This is when you are using the optional connected.
Yes.
Okay. And what is
So
it?
so for Bluetooth, starting in an unconnected state, by the time you send your packet, it's going to take 100 milliseconds because you have to set up that connection. Whereas a Bluetooth LE, you don't have to.
No, I guess my question is for the Bluetooth LE, since it seems like there are two different ways you can communicate. One is connection oriented, the one is without. 6 milliseconds.
So that's without the connection.
Without the connection.
Yes. I would expect if you set up a connection, it'd probably have a latency similar to the Bluetooth VR. Both protocols use the 2.4 gigahertz band, so that's important because that means that they can both use the same physical antenna to communicate, and they both do frequency hopping. So the frequency hopping is good because it prevents interference. So basically, what it means is when you're communicating your data, you and the person you're communicating to are both jumping around to different frequencies, and so you won't get as much interference from other sources like Wi-Fi or whatever. And it also is helpful because of multipath fading, which means when you're sending a signal, it'll maybe bounce off some object or a wall or whatever, and then come back, and then so you're getting this echo, and the echo is basically just noise to you. So if you're frequency hopping, then by the time you get that echo, you've already switched frequencies, so it doesn't interfere with you. And then you have your max throughput, which is for Bluetooth BR, it's about 3 megabits per second, and that's with your sort of standalone Bluetooth BR. They have additional things you can add to the Bluetooth BR, which like you can integrate it with 802.11 Wi-Fi hardware and be able to get like about 24 megabits per second. But with just a standalone Bluetooth hardware, then it's 3 megabits per second. And then the Bluetooth LE has 1 megabit per second throughput, but your actual value is going to be like about a quarter of that. And so the Bluetooth 4.0 specification also specifies something called GATT, which is sort of this abstraction for your devices, and it provides sort of a common interface to similar devices. So you might have like say your device is a heart rate monitor. So there's actually a well-defined heart rate monitor interface on the GATT website, and if your device is a heart rate monitor, you want to use that interface so that any other devices that want to talk to a heart rate monitor can easily find your device and know how to communicate with it. And they have specific UUIDs, so you should use the UUID that's specified by GATT, and you can also create your own devices with your own UUIDs if you want to. And so basically you have different services for GATT. So one service might be the heart rate monitor service, for example, and then the service has characteristics. And so a characteristic, you can kind of think of it as like a register that you can read from or write to. So a heart rate monitor will have a register that you can read from and to get the heart rate, and then maybe it has another register that's like an on-off switch that you can write to turn the heart rate monitor on and off. And
so these UUIDs, are they for profile or service or characteristic or for
the each one has its own UUID.
So like each characteristic has its UUID.
Right. So the heart rate monitor has a UUID of 180D, and that's actually for the service, but the actual register you read has a different one. And you can have multiple services. So if your heart rate monitor has it's battery operated, you can have like a battery service also. And so to get started, you can, if you want to set up like a client on your Linux machine, you can use HCI tool and GATT tool. And so you can call HCI tool LE scan, which means low energy scan, and you'll get a MAC address. And then with that MAC address, you can call GAT tool to so for this command here, I'm calling GAT tool with the MAC address that I found, and then -t random means that this address is a random address. You can have like a randomized address that you just made that the device just made up, or it could be like a well-defined MAC address, which you would put public here. But in this case, I put random, and then characteristic description. So these are all the actual characteristics that I showed from the previous slide. So that'll list like all these different ones. And then there's also a different command to list the services if you want to list the services. And then so yeah, it lists these here. Here's the UUIDs, and then different handles that you can use to communicate with that register. And then you can read from the register. So right here I'm reading from the E handle. So that's with this UUID, and it returned a value of 64. 64 is in hex, so this is actually 100 in decimal. And then you can also write to another register here using this command. And then in this case, I'm writing to handle 2, and I'm writing a value 7. And so this is a screenshot from the GAT website about a battery level characteristic. And so you can see this assigned number here is 2A19. And so if I go back to this, to right here, I have the UUID of 2A19 right here. And that was with the handle E, and that was what I was reading from. So when I read from it, I got 64, which is 100 in decimal. And so 100 is maximum value here. So that means the battery was full. And so these are the kind of like specifications that you can see about what, how to return it. It's a 8-bit integer, and you get maximum, minimum values and things.
So
like
why
that.
do they have handle when there is also UUID? Or is that
Handle.
purely something of GAT tool and nothing to do with Bluetooth? So what I mean by that is like you're giving attribute 000E. Why not just 2A19? Given that also appears to be UUID.
Yeah, I'm not sure if that's part of just GAT tool or not, because I tried to find like good stuff on how to implement the actual server, because it's like client side. I'm reading from it, but there doesn't seem to be like too many good libraries or documentation on how to do like on the server side of this. So that was one thing I wanted to say, is like especially for like your Arduino or Raspberry Pi or something like that. Well, Raspberry Pi you're running on Linux, so it's probably okay. But for something like Arduino or Beagle or Mbed, there's not too many like useful frameworks for implementing a server, and so yeah, I think it's just a little bit immature for that at that point. One thing right here is you can actually download like an XML file describing this or describing a service or whatever. And so one thing that I was looking for was some sort of framework that could take that XML file and then generate some like all the functions that you need to implement. But I couldn't find anything like that. But I think that's the idea with these XML files, is that you can you should be able to plug it into some framework and then have that framework generate all the functions that you need to implement, like when somebody reads from this register, for example, what to do and what to return.
Okay, I will talk about the iBeacon. iBeacon is an indoor positioning system for Apple, and Apple provide the protocol, and some other manufacturer will design the hardware of the iBeacon. This is one iBeacon hardware, And beacon hardware's transmitters, they keep broadcasting Bluetooth low energy signals, and it helps to detecting the presence of an iOS 7 Plus or Android 4.0 Plus devices, and this system will be used in retail stores and hospitals, and sometimes in museums. An iBeacon system is made up of four parts. The first one is hardware. This iBeacon hardware includes a microcontroller with a Bluetooth low energy radio chip and also a battery. The firmware is used to control the characteristics of beacons. It can modify the advertising interval and transmit power of the beacon hardware. And then there is a cloud infrastructure. Because the iBeacon hardware will only produce their ID to the Bluetooth devices. So that if you only get the ID, it is useless signal. The cloud will help to pass all the received beacon signals and provide some advertisement and some signals of the iBeacons. And there is also a mobile SDK needed for you cell phone or tablet to communicate with the iBeacon cloud. There are SDKs for iOS and also Android. The power of the broadcasting is different if you set the different range of the broadcasting. Yeah. There's also a picture showing back there about the power consumption. It's the battery life of an iBeacon is around. It really different from different kind of iBeacon hardware. It varies from 2 to 3 months to maybe 2 years. This is an example of the data format received by your cell phone. It's made up of the first 2 bytes are the Apple company identifier and followed with data type and data length. There will be a UUID for each. For the iBeacons in same area, they will share the same UUID, and for some sub areas, the iBeacons will use the same major value, and they will have different minor value for each different iBeacons. And also, you will receive a power power value, which is the power the power of the signals you receive. The app estimates the distance from iBeacon to devices by the RSSI, which is the power you received of your device. The accuracy of an iBeacon detector is around 0.5 meter to 1 meter. It has 3 different ranges. One is the immediate, which is around several centimeter, and also a near range, which is maybe 0 centimeter to 10 meter, and also a far range. Only within the near range you can detect the iBeacon either accuracy of 0.5 meter to 1 meter. There is also an indoor mapping SDK for iBeacons. They can map indoor floor plan, and you will need at least 3 beacons on the wall, and you need to hold your cell phone and walk from beacon to beacon and tap the phone to each beacon so that you can get the floor plan of indoor space. Once you get the map, you can export it to the cloud side, and also you can monitor devices in the space. And I have downloaded an SDK for Android and run the demo on a tablet. Actually, if you have devices which can detect Bluetooth low energy, you can find the device on your phone. As you can see the demo, you can detect the distance of iBeacon here, and if you move the iBeacon far away, there are 2 iBeacons here in the room. I'm not quite sure which one is this.
Yeah, I also see 2 estimates. So
Yeah.
Anyone else have an estimate here?
There was one like 70. There was like one when I was sitting over there. There's one like walking
I
around
think
the
this
hall.
one
There has been one walking around.
Yeah, because I see 2 out here also. So
yeah.
Okay. Anyway.
Yeah, you can see. Maybe you can move it really far. Yeah, you will see it move on the. And also there is a notify demo. If you enter the range of the iBeacon, it will give you a notification that you enter the region. Also there is a demo that you can change the manner value of your iBeacon device, iBeacon hardware. So that's all for my presentation. Is there any questions?
I have a question about the difference between Bluetooth AE and Bluetooth LE. Are they different hardware or just different software stacks?
It's different software because they actually share the same frequency band. So as far as the antenna goes, it's the same antenna. But if you wanted to, I mean, I'm sure like a lot of these Bluetooth devices have built-in hardware for that protocol. So maybe there is some differences in hardware.
Yeah, so I guess it's part of so usually on the phone side, the chips would support both. Okay, so so hardware is the same, they can share it, and thing is you're less concerned about the power implications out there. It's really on the other side, namely your devices, sensors, or whatever, where things matter. So you basically have essentially you have 2 kind of devices, right? I mean, what you call as Bluetooth Smart and Smart Ready. So the Bluetooth Smart ones are basically again same radio supporting both. They are less power constrained, but then there are also chips which only support the Bluetooth Smart part, the low energy part. In which case the hardware is the simplified version. And kind of you can sit down. So there are a couple of things that the reason why this technology kind of has caught on. Well, so firstly, obviously, anything which is labeled Bluetooth has a big advantage over any other type of radios. Okay, so ANT and Zigbee, they never really penetrated into the phones. Okay, and
So leaving that issue aside, a problem with the classic Bluetooth always was connection oriented, the big latency. And so sensors were like, let's take the heart rate sensor. It has to send out, like, usually the way they work is every time there's a heartbeat, they kind of send out a packet. And your heartbeat and all, I mean, that's fairly low rate signal compared to sort of what classic Bluetooth was designed for. So heavily duty cycle sensors which maybe wake up once in a while and send something out, their classic Bluetooth has a huge disadvantage because every time you're sending a packet, so you really have two choices. One is you go to sleep, and then whenever you wake up, you're taking that 100 millisecond or so of penalty and energy associated with it. Or alternatively, you kind of keep the connection up. So what BLE kind of lets you do is to kind of give you this other mode of operation where you have a very rapid sync happening. Okay, so essentially no connection. So that's one part. The other part is actually the reason it kind of caught on quite a bit is that the way these things are implemented, there is no pairing needed. So I don't know if any of you use any BLE devices, but one big thing that you would notice is that unlike, let's say, your headsets and all where there's a whole pairing option, none of that is needed out here, which is why, like, for example, I was saying there are two ST modes out here, right? So, so the basic interrogation of what are the devices, kind of getting some information from them, from their advertisement packets, is something which does not require any additional thing. So the way these things like iBeacons and all work is that they all send out advertisement packets, and any phone is capable of receiving it. Okay, so like he was showing for Linux the scanning part, and then you would get a list of all the devices in the neighborhood, what their UUIDs are, what services they provide, and then you can interrogate them. So the way iBeacons work is they actually put this information in the advertisement packets. So any iBeacons around you, you may not have seen them previously. Your phone would be able to interrogate them and learn what their UUIDs are. So one thing that iBeacons have is they have sort of within the payload, they carry as part of Apple defined protocol some additional information. They call it major ID, minor ID, for example. So typically the way the applications are designed is your application. So let's say you are UCLA and you want people visiting this campus to get some information around here. So you will release an app, a UCLA mobile app, and you would assign UCLA's iBeacon to have some particular major ID, minor ID, which your application, which people have downloaded, will look for. So that so that application will tell the OS, hey, I'm interested in iBeacons with these major and minor IDs. The OS all the time is scanning, okay, for these advertisement packets, which may be coming from all sort of devices. Any BLE device would be sending out advertisement. Those BLE devices, which are iBeacons, would have a special payload, and then the OS scans that payload and then looks for major and minor ID within that. And then any application which has subscribed to it, it will inform it, hey, I saw an iBeacon matching the major ID, minor ID that you look for. And then the idea is that that application would go around and sort of take that, hey, I saw this major ID, minor ID, then contact some cloud service and do something around it. So, for example, it could be that someone visiting out here, UCLA may deploy iBeacons with a common major ID all over the campus, but maybe the minor ID differs from building to building. And then when the app sees iBeacon matching the major ID, then it will look at the minor ID, consult a cloud service, pull up the floor plan of the building, and then display it. Hey, you are in this building. This is the map of the building. So the idea is kind of it works in concert with one big reason, or one thing that Apple kind of pushes for this thing is that the privacy control resides on your phone. So no one is tracking you. Your phone is not transmitting anything. Your phone is just listening. The iBeacons are just transmitting. Your phone gets to know that, hey, I'm seeing this iBeacon, and then kind of works with the cloud service. So there's a privacy advantage. You could do the other way also. You could have your phone be an iBeacon transmitter. And in fact, as of Android 5.0, which came out just recently, and iOS for a long while, your devices could be transmitters also. So you could walk around and have your phone transmitting with some caveats. So you could even, like, I could advertise like, hey, wherever, essentially a phone becomes a iBeacon that you're carrying, iBeacon the transmitter. So you could imagine other kind of applications out there that whenever you are near your friends may get to know that, hey, you are nearby, and perhaps have reminder type applications and all, which are based upon social proximity. So BLE sort of gave low duty cycle, no pairing needed. That's kind of the other advantage. And thirdly, because of these additional stuff like iBeacons and all, you have additional kind of services emerging on top of that basic infrastructure. One other pragmatic thing is the following. So iOS devices, if you were to use classic Bluetooth, let's say you want to create a sensor which were to speak classic Bluetooth, usually in classic Bluetooth, these devices become visible as a serial port device. A very common way for sensors using classic Bluetooth is using what is called as a serial profile. Apple requires that your sensors be based upon a chip that they sell, which has some cryptographic mechanism. So you cannot make a sensor and expect it to work with the iOS devices unless you license that particular chip from Apple. But for BLE devices, there is no such constraint. So you could be anyone, make a sensor, use a BLE radio, and it will work with the iPhones. Android always had been more open in that direction. So for these lower rate sensors, which essentially is a lot of stuff like, I mean, your typical smartwatches and all, these are all kind of BLE type stuff. You can do a lot with 1 megabit per second, incidentally. So, so it also, I guess, at least within the Apple ecosystem, it also made possible sensor devices which are sort of license free. You can don't have to seek any special chip from Apple to kind of for your devices to work. So a lot of sensors are emerging. A very one paradigm that you would see with a lot of these things is that the basic communication is this connectionless. That is, your devices advertise, anything important is carried in these packets which are connectionless. But then for things like you want to configure the sensor or things like that, then you switch into a connection-oriented mode, and then, for example, your app could configure the sensor and things like that. So a lot of stuff now, for the reason that it's easier to penetrate, is just BLE only, and you can kind of do a lot around that. So it's not a replacement for high rate stuff. So if you are into whatever, a headset and these kind of things, BLE will not work. But for most applications, it's actually a very interesting thing. And you can download apps on both iOS devices and now also on Android devices, where you can literally look around. Like, for example, I was looking, so I have this app called BLE Explorer. What it does is it basically looks for advertisement packets from all devices around it, and I can get to see what it is. And sometimes it's kind of interesting. People sometimes give their devices their names. Okay, so you might even see whatever John's XYZ device. So there's a bit of a privacy leakage happening even just from that basic information. But you can certainly keep track of these BLE advertisements. You may not be able to connect with them necessarily or configure them. They tend to be password protected and all, but at least you can kind of keep track of what is going on. So it's an interesting technology that, yeah.
So the range of the Bluetooth LE was 100 meters as well.
You know, that really depends. Okay, so the range is really a function of the type of radio that you have and all. BLEs, so the radios come in sort of various power ranges and all, but 100 meter is kind of the upper end. You will see a lot of devices which only aim for like a 10 meter type ranges and also. So I think on his slide I saw that for BLE it said less than 100 meter, and for classic BLE 100 meter, but these are upper end kind of numbers. Okay, they don't have to kind of follow that. And in fact, iBeacons that you get, they usually, the more sophisticated hardware that they have, they let you control both the transmit range. So you can basically have an iBeacon which is configured for, like I have some of these deployed in my home, and at the low power setting, you literally have to be within 3 or 4 meters for them to listen. And at the high power setting, I could be anywhere in my home and still kind of work. And the other thing is the rate. So the iBeacons, at least the guidance there is that they could range anywhere from once every 5 seconds to 5 times a second. So it's a fairly large dynamic range of transmit rate, and that obviously means that like if it is once every 5 seconds, I could visit my room and get out of it, and it will not even detect that I was ever there. Okay, and the flip side, of course, is once every 5 seconds, but then you're burning a lot more power. These things are coming in form of jewelries, luggage tags, so like you can things where you can just attach them to your suitcase, and you'll whatever you can sit in the chair at the airport, and when your bag has come out, it will just inform you, hey, go pick up your bag. These kind of applications are you can imagine as well. So a lot of sort of creative things people are doing around it. Recently, kind of the folks here at UCLA event, my group is doing a lot of work in iBeacon, so they contacted us saying they would like to have an app where visitors coming to events at UCLA kind of get the program guide and all as soon as they kind of come out here and all those kind of things. So these are typical apps. Some stores, like if you go to Apple Store or Macy's, they actually have these kind of deployments. So two big ones: proximity slash location, and then kind of a lot of the sensors which previously had to work with the higher power, higher rate Bluetooth can now work with lower power thing, more rapid pairing, or really no pairing, and also freedom from Apple's licensing requirements. So there's a whole bunch of kind of things which have happened around that. Question.
Does the iBeacon, do you actually have to be moving for it to detect, like, to synchronize maybe your exact position, or can you just stand in one position?
You can actually, for better stuff, you have to stand in one position. Okay, and the way it works is so Bill alluded to it. So the way it works is the following: in the packet, there is a field which says that if the receiver was 1 meter away from the transmitter, what signal strength it should see. Okay, so and that you have to pre-calibrate. So let's say you design an iBeacon, you can pre-calibrate and say, okay, if a receiver was 1 meter away, then the signal strength it would see is so many dBm. Now, of course, the packet that you receive actually would have some particular signal strength, and then you can kind of do some propagation, radio propagation related formula to compute what the distance is. The problem that comes is that the signal strength reported by different phones are pretty variable. Okay, so the distance estimates are not that great actually, and if you're moving around, if your iBeacon is a relatively low rate iBeacon, you can move a lot. If it's set to typical setting often is around once per second or something like that. You can move a lot during 1 second, even at sort of walking speed. So to answer your question, actually it works best when things are relatively stable. Okay, let's move on to the next one.
So how's the internet on this computer?
I can turn it on. You
Yeah,
need the
'cause,
browser.
Yeah, it would be good to have a browser for the demonstration afterwards. Time pending.
The
Also,
internet
I have
here
a,
is always flaky, unfortunately.
yeah,
But let's try it.
Also, I have a video on USB, which I obviously couldn't email to you. That it's only about a minute long. That if you have MP4 player, that would be
Yeah, I have an MP4 player, so I can play off that. Yeah. I don't
If it
think
doesn't,
it's not going to cooperate. So yeah, you can just do the video.
Okay, great. Okay, good morning, everyone. I'm talking about Wyleodron, which is a web-based app program for programming embedded systems in multiple languages on multiple devices. Founded in 2013 by a small startup group based out of Romania. They started the design of Wyleodron at a hackathon. There was only 3 original members. Since then, it's been steadily growing into a startup business with 9 members. So we're talking really small company here, but they're doing some pretty great things. They've won a whole series of awards, further awards in startup, mainly from the original startup and a few follow-up presentations and demos. And from their brief introduction, what they are, just to read it, WileYodrin is a service that allows programming and controlling development boards directly from a browser. You can write, store, and deploy programs from the cloud. Moreover, you can modify and watch the board's parameters in real time, no matter where the board is located. So what does this mean? The key ideas behind WileYodrin is that it's an all-in-one browser-based programming service. So you log in online to wileyodrin.com. There you have your login, all your programs are there, or your embedded devices are there. The main thing that differentiates them is that the embedded devices you have access to will all be connected via the internet. So this means Raspberry Pi, which is one of their key ones they support. You plug it into either a wireless device or into the Ethernet. It can be plugged in anywhere in the world, right next to you or in your wall or on the other side of the campus. And when you log in wirelessly, you'll be able to start programming it. So the two big advantages to that is one, remote control. You can be anywhere in the world and start adapting and programming onto your device. And then, of course, as well, if you have a wireless plugged into your embedded device, then you can start programming while it's still essentially mobile, which would be useful for robotics, for example. The other key feature is WileYodrin really focuses on being as easy and simple to use for beginners. So the whole iteration from writing a program to compiling your program and installing it onto the device is one click. Some additional features that WileYodrin has includes a bunch of sensor data. So they have inbuilt graphs, pie charts, temperature thermometers that you can see in real time up on their website. So when you run a program, you can get their own custom interpretation of how that data looks. So it's easy for you to see. Of course, all their programs are stored and saved on the cloud. There is no saving required, it's auto-saved. And I'll go into more detail as to what languages and devices they support. It's ever increasing, but it's fairly diverse. For more advanced users, there's a shell, so you can directly access into your embedded device and try to line-by-line shellcode manually onto it. Say you wanted to turn on specific GPIO pins. And then lastly, part of their feature is that not only can you talk to with one embedded device, but multiple devices can communicate between each other. You can also set up a program that will talk to a mobile device, as well as set up a web browser online that you could post data to. And then lastly, they have a lot of video tutorials and documentation on their website about how to use their program, so anyone can learn from the ground up without really knowing anything about embedded programming. Their current supported hardware is primarily the Raspberry Pi and the Intel Galileo. They also claim they have beta testing on the Intel Edison. Up until 2 days ago, I couldn't program on the BeagleBone Black, and then that became available, so this is something that's constantly being updated. And then also the Z board, which is a Xilinx-produced all-programmable SoC. They claim in their documentation that there is a way to set up and use one of these, though I'd imagine that would be fairly questionable as to whether it actually works yet. It would be essentially in alpha testing. As for the software they support, so many languages. I'd say Python is their primary base, but you can also program in JavaScript and C, C++, Objective-C, Java. All of these will have supported compilers on there for you to run. Their big selling point, though, is visual programming, which is their own sort of drag-and-drop visuals. The picture on the right is what it looks like. You have a whole bunch of features that you can drag and drop, build your own structure. You can build for loops. You can build intelligent design, such as like nested loops or grabbing data and outputting data to your output. When you are running the program, as you real-time build your visual programming, you can see the either Python or JavaScript code that is generated at the same time. So if you want to then switch over to Python, you can very easily do that. And then, of course, all this programming can be saved, exported onto your computer if you need to save it for a later date. Okay, so some more detail about visual programming, some of the features that they have built into their WileYodrin at this stage. The most exciting thing is probably their social features. So whether you're sending to and from email, that's Gmail or Yahoo, Facebook, Twitter, or Twilio being used to send SMSs to your phone, the WileYodrin software can receive data from any of these social medias or post it. So you can receive data from your Facebook page, and if someone makes a post, it can detect that and send you a Twilio message that says something has been received. The complexity of this is as you build it, but the sensors are all there for detecting these. It also handles multiple peripherals, including a 7-segment displays or LCDs, if you have those plugged into your actual Raspberry Pi or whatnot. They have built-in features for weather and radio grabbing that specifically internet and weather radio. And as I said as well, they feature a system which I couldn't get operating, but they claim you can set up a local web server and you can post data to the web server or use the web server HTTP URLs to control your actual Raspberry Pi as well. They also have features which I didn't test, but they work for Rapio and Lego Mindstorm Robotics, as well Bitcoin CG Miner. These are just some examples of the apps that are already built into their software that, if you had particular interest in these features, would be very easy and convenient to set up and start running your embedded system for them. In terms of the actual their model, so as a tester, I had a free account. It took me 30 seconds to set up. They only allowed me access to uploading one of my own boards, so I use my Raspberry Pi, and I'm allowed up to 3 different programs, a program being multiple files. Of course, prices vary as you want to build up your operating, so this is how they try to make their money. So how do you actually use the software? So like I said, first thing you have to do is you need to log in. You can log into an account via Google or Facebook, GitHub. If you don't want to log in as an account, you can just click into their public domain. You can start using boards. They're directly available. Of course, anyone has access to everything there. And also any programs that are written in there, no login required domain will be deleted within 24 hours. But it's there for testing, so they're trying to make this program as easy for anyone to try out. The process of actually setting up a board took me maybe half an hour maximum, very painless. You need a SD card, you take their image and install it on it. Then for every embedded device you have, you'll be given a specific access token. You attach that in a JSON file onto this SD card, plug in your SD card into your embedded device, in this case my Raspberry Pi, plug it into the wall in a socket, and voila, my account can see my Raspberry Pi. Multiple pre-made software examples. Yeah, so as well as being easy to set up your device, they have a lot of tutorials online. They have a lot of, when you're trying to generate your code, there's a lot of pre-made code there that's already made ready to use. Features such as flashing an LED or receiving radio data and streaming a radio to your Raspberry Pi. And as I said before, it's all one-click installation. So some final remarks. I've been playing with this software now for a couple of days, how I thought it. The good about the software is it's incredibly simple to use. If you don't have any experience with embedded programming, if you've never used a Raspberry Pi before, it's a good starting point for putting test programs on it, seeing it work, getting some real output data and real sensor results. For that purpose, for any sort of DIY projects or anything from a high school through to college level, it would be the perfect sort of starting point. The built-in functions they have work great. Once you move away from the built-in functions, though, I'd be concerned that you would start seeing more and more difficulty. Now, it's in constant development, still in beta stages, which is to say they're very open to feedback. If people had good ideas for devices they wanted supported with them, they'd be willing to do that. However, say for example, you wanted to use a device that wasn't supported. So I didn't mention that they support the Raspberry Pi, and with the Raspberry Pi they support both the Arduino and I believe it's the C-Kit Toolkit attachment sensors. But say you wanted to use your embed, well, you're essentially out of luck. You could manually program to try to support an embed attached to the your Raspberry Pi. However, essentially none of the visual programming features are there for you to easily and painlessly work with that device. The other major difficulty I found is, though they claim to support multiple languages, I found as soon as I moved away from Python, when I started writing my own programs, the compilers would sometimes just freeze and not work. So clearly they're there for ready-made, no need to build a make file. However, it's still a little bit buggy. Whereas I found when I was using visual programming and Python, I had no issues and everything pretty much worked first time. The other thing I'll point out is internet-based board access. So the pros of it are obvious. You can be remote, you can be wireless. However, say you don't need that. Say you just want to plug your board in via USB cable to your computer and program that way. Well, that feature isn't there, and so you do need to have a way to connect your device onto the net. And say your a Raspberry Pi has a USB, so has a CAT connection, so that's simple enough. But if you do not have the easy connection to put your embedded device on the internet and give it a unique web address, then you would find some difficulty. And then lastly, like all new programs, it did have some issues. For example, if my embedded device would be disconnected from the internet, it would be very slow on responding to realize it wasn't there anymore. And whenever anything didn't work, the software would basically just hang. So, like I said, when it worked great and was very simple. But as with most programs that have a lot of wrapper to make things simple, the debugging is somewhat limited. So now, assuming I can get this to work, I'd like to just run a little demo on some software that I ran. And let's see how we go. So, yeah, if you could help me, that'd be great. So, using the powers of my phone, I ran a 1 little minute video. There's no audio, so that's fine. Just so you can see, this is a program I wrote. It took me all of 10 seconds. And what it does is every second it loops.
Actually, you have to start it.
Yeah, I'm just pausing so I can describe it. So I wrote a program on my Raspberry Pi, which is directly connected to a sensor set, which had an LED, so not particularly complex. And I decided to know the all-important question of how many likes Nickelback has on their Facebook page. And if the amount of likes is even, then I set my sensor to my LED to off, and if I set it to on, I set my sensor high. So just demonstration shows how easy it is to write this sort of code and how simple it is to test. So with one click, program is now verifying that it's legitimate. Programming is now being sent to the board, which is next to my computer but isn't attached to my computer. We see the program is now on. You can see currently the amount of likes on Nickelback is odd, so if we flip over, the LED is on, lo and behold. And then I decide that I actually like Nickelback. I was actually surprised to find that if I just ran this for a period of minutes, about every 10 seconds someone else likes Nickelback, which is somewhat disturbing. And there we go, now the light's off. And after a few seconds, it turns back on again. Someone else somewhere in the world decided they like Nickelback as well. So that's just an example of how easy it is to write these sort of programs. And okay, if there's time I could show the software, but it seems like we have internet problems, so I'll leave it at that. Any questions?
So it's actually a pretty cool, I had tried it too. The only thing is that while they say that you can also put their software into an existing image, I made the mistake of doing it because it took hours for it to compile. So it's much better to use the image that they provide and kind of work off that, as opposed to kind of, I kind of went with the mindset, I don't want to disturb all the configuration I had done on my Raspberry Pi and kind of just wanted to install their stuff on top of it, but that took hours. But I think this thing kind of points to a couple of trends. Number one, I mean, we already saw with things like Embed and all that, the development chain moved, but this is taking also the management side of embedded systems onto the cloud, and that's kind of really kind of nice thing. So individually, none of the pieces that if you think in this are things that you have not seen before. The visual programming environment, if you have ever played with Lego Mindstorm, it looks very, very much like that, and MIT has had some of these kind of visual programming thing. And I think the coolest part out here is really the ability to manage everything from the cloud, as long as you kind of get your device connected to the internet. Okay, let's move on. So next up is WebSockets. You want to use your laptop or you have a demo? Okay.
Hello everyone. Today I will introduce WebSocket. What is WebSocket? So the key idea of WebSocket is it is a two-way communication protocol, and it is different from HTTP. And because we normally use HTTP, which is a one-way connection. Although we can do it like a pony, use it just like the client to send the information to the server, and the server get request back to the client. But they are both one-way collections. But this WebSocket is a full duplex
socket collection. For example, some web applications like messages, online messages, or real-time games, they need full duplex collection because they need real time. I will did so most browsers are supporting WebSocket. Why do we need WebSocket? In some cases, like live chat or real-time games, they need to interact on real time. And WebSocket is designed especially for these cases for its high efficiency. And we can use and also we can use other ways to achieve this goal, such as polling or non-polling, and they use HTTP to achieve this goal. For example, polling is an early method to implement interaction function. First, the client sends request to the server, and if the server has the data, it will respond immediately with the data back. And the client will send the request during a certain time periodically. So maybe this period, and it will send the request again, and the server will return the data back. But let us suppose, because sometimes the server's data does not change so quickly, because if the server's data almost the same at this line, so that the data will not change, but it will consume the traffic, internet traffic. So the data, the same data, but it will consume the traffic because the client does not know what the server's data happens. So these requests are really wasteful. Another way is non-polling. Unpolling is better than unpolling because the difference is that if the data does not change or the server does not have data ready, it will wait for this certain period of time, and only if the data is ready or the network after this time the network will be timeout. So the client will send the request again to find out if the data change. But when the server's data changes very quickly, the client cannot be sure whether the server data is changing. So, but it will send the request at this certain amount of time periodically. And this is the limit of the frequency. Like if it is like an online game, because it needs the data to transfer at a very high frequency. So it is real high consuming the traffic. So this is WebSocket, and WebSocket first it will establish the WebSocket session. They need the WebSocket handshake, and this WebSocket handshake needs HTTP protocol, but then it is socket socket connection, and the HTTP is a one-way connection. I will first tell the handshake. The WebSocket handshake is when the client connects to the server, it will send the HTTP headers like the handshake protocol, include the WebSocket version and the only if the server accepts the client's request, it will accept and return the HTTP handshake back, and they will then start the WebSocket session. It is established, and then they will use this two-way connection to communicate. And because this two-way selection is they both can send the message to each other. For example, if the server's data does not change, it will not send the socket back, and the client, if the client needs the new data, it will send the socket to the server. It really depends because they like the push notifications. Every site has new data, or they need to communicate to the other, to the server or to the client. Then they will transfer the data. Not like the polling or non-polling. We will send the request periodically to find out if the server has the data changed. That's the difference. And at the same, if no matter the server's data changes quickly or slowly, it will not be very traffic consuming. This is superb for the data that is not that data interval. The data changes interval is not certain. After the successful handshake, it will establish the WebSocket session, and and the server and the client will be in the collection. And this is the example, very simple example. This is the most important function. Like when the server transfers data to the browser will trigger this function. And these are in JavaScript. The web, because this collection is a two-way collection, and they are in sockets and not in HTTP. And HTTP has and WebSocket, they are not in the same way. But they are both based on TCP IP, and but in the WebSocket collection, it will use HTTP protocol to establish the WebSocket collection. That is important. That WebSocket also uses HTTP protocol in the WebSocket handshake procession. So here is an example to see the high efficiency of WebSocket. For example, when the user is when the client is 1,000 and 10,000 and 100,000, when the client is very small, they are not the polling is not bad compared to WebSocket. But when the clients rise to 100,000, it is the efficiency is we can see the efficiency of WebSocket. It can save the traffic, and it has very high efficiency. Here is a demo for WebSocket. Everybody can connect to the EEM202A WebSocket, and the password is WebSocket. You can use your laptops or smartphones. also connect to that.
Sure.
Yeah.
I still don't see when it was.
Yeah, you have to click on that.
Open file. Yeah, I like to open Firefox for you. So
Okay, what address you want?
One.
Yeah.
For example, for the chat room, now everybody can go to chat room, and so it is a real-time collection for the chat room, and also for the like drawbot. So we can draw here, and everyone can draw at the same time. The other people, what they will draw can be seen on the same drawbot. And another type of example is like the snake. It's a real time. It's a real time WebSocket. You can use the up and down. You cannot be pushed to another snake because you will die. And so this is like a very small online real-time game that use WebSocket to. If we use, if there are like many users in one game, it will also not be very traffic consuming. And that's all.
Yeah. So the main reason I wanted this particular presentation was that do you have something more?
No.
Okay. That for applications where sort of sensor type data needs to stream to a client, so there are two scenarios where this protocol is very helpful. So one is certainly where you are streaming stuff like graphs or whatnot over a browser-based client. So that's one situation. The other thing is that port 80 is something which most firewalls let through, and therefore being able to funnel real-time data over it is very useful in practice, and therefore again WebSockets kind of become very useful there as well. So while these applications he showed really have nothing to do with sensing or actuation kind of thing, but it sort of essentially in the same TCP session you're carrying HTTP type stuff, but you're also carrying real-time traffic, and that's kind of the main advantage of this one. Okay, so let's move on. Next one is FreeRTOS. So this is one of the more popular real-time operating systems.
everyone, I'm Zimu, and today I will do a short presentation on FreeRTOS. So, about real-time operating system, it's a system that can serve real-time application process data as it comes in, typically without buffering delays. So, it is mainly optimized for all the embedded or real-time applications. And the main thing is that it has an advanced algorithm for scheduling. So, Professor Srivastava has already mentioned a lot about this, so I will not talk about this here. And something about FreeRTOS, it is founded by Richard Barry and developed and maintained by real-time engineers, and it's been working for about 12 years, so it's not really new stuff. And some features I have cited from the official website. So first thing is that it's free even for commercial use, so you can save some cost. And then it's simple. The kernel contains only 3 C files, and it is well supported. You can seek for help both from the official support or from online forums. So I think it will help. And then it is easy to use both during your test and when you want to control your embedded device. So these are all some features I have cited from the official website. So this kind of remains to be examined. And one thing to clarify is that the FreeRTOS seems more like a real-time kernel than a real-time operating system because it does not contain some peripherals like TCP/IP stack or file systems. So it's not really a complete operating system. So if we want to use it, we'll need to link some utilities. So the first thing about there is FreeRTOS plus Netto. I will introduce this later. And then there's FreeRTOS plus FAT Superlin. This is some kind of really simple file system, and I have tried some really simple commands like fwrite, freeze, and make directory. And this works really simple and works just like the stuff we are using in our daily life. So then there's FreeRTOS plus UDP. This is basically a socket-based IPv4 stack, and it contains some Berkeley-like styles, APIs like receive from or send to or bind. So it's not really hard to understand. I mean, you have to add some sort of prefix like FreeRTOS when you use that, of course. And then there's FreeRTOS plus CLI. This is command line interface, and to use this, you have to first provide a function that can actually implement your command, and then you can map your command to this function, and then you register this command to with this FreeRTOS plus CLI, and then you can actually run your command. So while using this, you will need this FreeRTOS plus UDP and maybe this FreeRTOS plus IO, because you have to actually input your command to this device. And the last thing here is the FreeRTOS plus trace. This one here is a runtime diagnostic tool. So you may need it during your optimization, and it will collect some behavior data for you to do some optimization or analysis offline later. And so about the demo, I hope to do the live demo, but there's some problem with my laptop, and it just won't work with the projector these days. So I made some screenshots and hope it will work well. So for FreeRTOS plus Napto, this sketch shows basically what Napto do. It provides direct communication between the client and the resource. So you don't have to deal with all the configurations in the middle. So it's kind of convenient for IoT use. And I didn't really hack into the FreeRTOS source code, but I just tried to check the Napto part and found that it actually needs FreeRTOS plus Napto and the UDP part and the CLI part I have just mentioned. And so here I enable the local access and disable the remote access. So this is sort of convenient because I don't have to worry about the UID later. So this is a hard-coded URL I will put into the device. So here is EEM202A.local.demo.net, and later I will use this URL to access my device. And so if we are using some remote access, we'll probably need some IDs like UID, but as we have just enabled the local access, this won't really hurt much. So here I disable the DHCP, and I will have to do the address configuration manually. And here's some address configuration. So for the user interface, I put it in a directory locally because I can download it from the cloud because this is just a local demo, and this directory contains some user interface. And I have started the virtual device interface here, and it says it's working. Actually, this demo is about some tick counts, so the count will change, increase by like 100 every second. But we're just using a software simulator, so there's not we're not doing things about the real time. So 1 millisecond takes about 2 milliseconds on my computer to execute, while the data provided on the official website is 40 milliseconds. I don't know why they took that much. So here I will just start the map search, and I found the local demo virtual device here, and I will just click in, and it has this sort of things. I'll check the stats, and it says like this. So I didn't take the screenshot of the count because it just won't move. So here I want to do some brief. I just want to show some pros and cons of FreeRTOS while comparing it to some other RTOS. So I chose the micro C OS, which is also somewhat popular in some regions. And the advantages of FreeRTOS can be it takes less space in ROM and RAM. So it takes about just half of what the micro COS takes, and then it can reduce some cost in RAM through utilizing the coroutine with such something like stack sharing, while the micro COS can only allow some tasks with independent stacks. So ROM and RAM are really precious resource for embedded systems. So I think these two really important. And then it can keep the task with the same priority. So it will be a bit tricky for the micro COS to deal with the situation where we need to display the results of two different tasks at the same time. But I don't know whether it's an advantage or disadvantage here, because on one hand it can deal with the situation I have mentioned. On the other hand, it will just disable the micro COS doesn't allow the tasks have the same priority, but this can sort of eliminate the uncertainty in the execution time, and this can just guarantee the stability of the software. And of course, the last point here is it's free for commercial use. And then there's the disadvantages of FreeRTOS. First of all, it's simpler in function, so I think this is some kind of side effect resulting from it takes less space in ROM and RAM, because it has less APIs. And then there's less supporting peripherals. Micro COS also supports some peripherals like USB, GUI, but FreeRTOS is catching up really fast this year, so as we can see. And then I just browsed through some forums and noticed some programmers claim that during some optimization provided by FreeRTOS, there's some bugs. But that's really rare, so I don't think that's the case. And there's some other trivial parts. So FreeRTOS provides a convenient method to deal with interrupt. So, but through using, I think the all the variable names and function names provided by FreeRTOS is just a bit long. It has kind of really long prefix, and I just think it's annoying to type so long things. And there's some tricky things about the feature it mentioned on its official website. It said it's simple because it contains only 3 C files in the kernel, but you have to make your device work, so you can't just need this kernel. You also need some other peripherals, so that will take much more than 3 C files. And so that's my presentation today. Thank you.
So FreeRTOS actually, it turns out, I was looking at this, the most popular among the small operating systems. So it's pretty widely used. I think much of it is because it's pretty highly portable. So it's available on a variety of different platforms. So that's kind of a nice thing. So anyway, relative to kind of the other stuff out there, it's just very commonly used, highly portable. Let's move on to the next one. So this one is actually a new one which I saw. I have never used it or familiar with it, but they claim as the operating system for IoT, and it seems to also, it was the next one in line in that list of the more popular ones, so I thought it would be make for a good presentation.
Thank you. Good morning, everyone. My name is Shenjie Bi, and today I will give you a brief introduction to the operating system IoT. This is the outline. Today I will go through the basic background features, usage of IoT, and after that I will give you a brief demo. So just like the presentation before, IoT is also an open source operating system, and it's designed special for IoT system such like wireless sensor network. It's totally open source, and you can download the source code from GitHub, and it can also run on different platforms, including some very low power embedded device and also your personal computer. And IoT allows C and C++ application programming. Initially, this OS is developed by Free University of Berlin, Hamburg University of Applied Science, and French Institute for Research in CS and Automation. So now we know what is IoT generally, but where is the idea come from? So in 2009, a project named Ferrovial Tracking Firefighters started at Free University Berlin. Generally, their idea is try to build a wireless sensor network, and using GPS technology and IoT technology, they try to locate firemen and protect them. So as part of their project, microkernel named firekernel was developed, and this firekernel special focus on reliability and real-time guarantees. And IoT is mostly inherit from this microkernel. So in 2013, last year, this operating system goes public. So the design goals of IoT is energy efficiency, hardware independent development and a high degree of modularity. It's named a friendly operating system because it's developer friendly, resource friendly, and IoT friendly. You can just use standard programming such like C and C++ and standard tools such like GCC, and also based on microkernel architecture and the tickless scheduler. It has a good it has a energy efficiency, and you can just use normal protocols such like IPv6 and so on. And so when we compare IoT with other famous OS, for example, when we compare IoT with Linux, we will find IoT use much less memory, so it can run on some very low power embedded device. When we compare it with some Tiny OS, which from UC Berkeley, we will find it supports better. It has better multi-threading ability and has better modularity. So IoT has a lot advantage over other operating system. And this operating system can also run on different architectures and boards. For example, Arduino embed, and you can also run it on some other ARM embed, and it supports a lot of architecture and boards. Besides, I believe virtualization is also a very good part. So when you use this virtualization, you can just generally it means you can run on a virtual board in your computer, in any Linux computer. So if you do not have a supported real hardware platform, but you want to try out IoT, you can just run this this board. This board is named native board, and it's building the source code of IoT. Also, it can be used to debug without any limitation and requirement. So after that, I will show you how to use this native board on the computer. I will show you three brief examples. Just okay. Here we go. This is the first program named default, and
you need to do string mirroring.
oh,
You have to mirror your screen from your display, or move the window. Just move the window to the window on your thing. You slide it onto the screen.
move the window like this
No,
one.
not that.
So first get the window on your screen, your demo window.
Terminal.
Okay. Now drag the terminal onto the neighboring screen. The other way. To the right hand side. To the right hand side. Yeah. 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 Okay. Yeah. Here you go.
Oh. But I cannot see it.
Okay, so then you do. Okay, I don't think I can help you because all your stuff here is in Chinese, but let's try. Which one is preferred? This?
Oh yeah.
Okay. Display. Okay, array. Yep, correct. What does it say?
Make the window become one.
Okay, just hit OK. So
Thank you.
just accept it.
Okay. So sorry about that. So first we can enter. This is IoT. All the source code of IoT operating system, and you can download it from GitHub. So there is some examples here that I want to show you. So on this example, you can see there is a makefile, readme and beam and man.c. So you just run make to compile the program, and after that, you run the use super as a super user. You run make term. So here you can see generally this is how this IoT native TOS is working. So it also shows us two LED, a green one and a red one, to show us to tell us this is a virtual board, and this IoT welcome to IoT. That tell us it's working now. So in this case, we have this command, and this is their description. So we can run it. We can use this command to see if it works. For example, if we try to type PS, it tells us the information about the running threads. And for example, you can also try other commands. For example, cur, it tells us now how much power this board is using. Also, for example, we can try this one. These two commands generally means they can return us some PRNG. It means random noise. It is a random noise generator. So every time you run this command, it will give you some random number as random noise. You can also use other command to send and receive message. You can also build like two bots like this to send message and receive message from each other. After that, I will show you another example. For example, this one. IoT and C++. This program generally it want to tell you you can write C and C++ in one program in IoT. So if we go through the code a little bit, we will find there are two threads here. So the main thread it's use C++, and there are another thread named thread it use the C language, and he prints something, try to tell us it works. So same, we try to use make to compile, and use make term, and will tell us you can use C, and in another thread you use some C function here, and in this thread you use some C++ function. And another example is named IPC. This example it's just tell us there are some inter-process communication in IoT. So when we run this program, you can see an endless loop. So we stop it. Generally, there are two threads in this program, and every time the first thread will send a message to the second one, and the second one will print a got message, and after that it will return a message to first thread, and the first thread will print the number it received from the second thread. So the number will keep increase, and it is endless loop here. This is just some very simple example of it. So if you want to try other more complicated but interesting example, you can go to their website, and there are also many useful results there. Yeah, that's all. Thank you.
HomeOS, can you do it in 10 minutes?
Well,
Okay, let's try.
yeah, I'll try. I just skipped the video. Okay, so hi everyone, I'm David Urdaneta. I'll be talking about HomeOS. It's just very briefly a quick overview of it. It's just an operating system designed for home automation. So what I'll be talking about today, first just describing what HomeOS is, followed by the motivation behind it, like why HomeOS is a bit different than other home automation abstractions. Then a bit of the software architecture, so how it is divided just like most operating systems in different layers, followed by the design, how it's actually designed and implemented, and how, if any of you would like to try it, how to download it and set up the environment for it, some examples that I'll go through, and then not a live demo, but depending on how much time we have, sort of a demo how you could use it for a specific sensor. So what is HomeOS? As I said, it's an operating system for connecting in-home hardware. It works like a PC abstraction. So where the devices are like the peripherals in a PC, and the applications that control these devices are like the applications in a computer. And for the user, the devices will appear just like for a user in a computer, the peripherals appear. So why HomeOS came? Why was it created? So there are currently two dominant abstractions for home automation systems. One is network devices, and that works with interoperability protocols. So like Z-Wave, Speakeasy, all these have the same protocols and communicate to one hub. But the management is kind of hard because the user has to directly deal with the hardware. While the other set of abstraction is the appliances. We have monolithic, different separated systems, each with its own set of tasks and devices, but it's hard in the sense of extensibility. If we want to add a new device, we have to create a new set of tasks for the user to use just for that specific device. Then HomeOS is something in between. It tries to create this operating system layer between the user and the devices. So as I said, we view this abstraction from devices to be the peripherals in a computer. So then the tasks that these devices, that use these devices will be the applications from a computer. And if we want to add a new device, it's like plugging in a peripheral. If we want to add a new task, it's like writing a new application and installing it. And just to give a quick overview, here we have many devices that would communicate with the home OS through a specific set of protocols that home OS already recognizes. If you want to add a new protocol, then you could add it, write it onto the home OS. And then the user writes its applications and communicates directly with home OS. So it doesn't have to know too much about the devices, just the home OS will give it the functionality and what kind of resources does each device use, etc. So, but not directly with the hardware. So it facilitates it for the user. Okay, now the architectures. It's divided in four broad layers, going from the application layer, how the tasks are going to be using the devices. The management layer, it's a bit of controlling the different devices, what can be used, what cannot be used. The functionality layer will talk about the functions that a device can use. I'll go into deeper explanation after this. And then the connectivity layer. So it relates directly on how to connect to devices. So the connectivity layer just will provide the basic connectivity to them. It'll have a set of protocols already installed, so like the Z-Wave protocol, and it'll be detecting or discovering the different devices. Once it gets those devices, the functionality layer will abstract the functions from these devices. What can they do? What can they do for the user? So the user just needs to know what functions they have. For example, if we have a camera device, then the functionality layer will abstract these following set of functions, like get image, get video, move up, move down, or if we have a dimmer switch to get or set how dim the switch is. Then next up is the management layer. It's more for is managing the devices. We create our data log based rules. So some devices can only be used during these times, so only by these users, depending on the priority, only this day of the week. So it kind of just sets restrictions on the use of the devices for security purposes and to verify the settings of them. And finally, the application layer, where the code is developed it's written by the developer, can use any of the devices that we talked about before, and it uses the abstract interface of the function layer. So it just needs to know the functions of the devices, that's all. Okay, and home OS mainly works with modules. The applications are modules, the drivers are modules for home OS, and they work with this set of APIs. So you can start a module, stop a module, register the services. And whenever you discover a new device, for example, the connectivity layer will run a discovery protocol module. And once it's discovered, then it'll install a functionality module that will abstract the functions from it, as I talked about it before. And the way modules communicate with each other are through services, which have a set of IPAs for themselves too. And also, part of the design is to manage the tasks, which would be on the management layer. If we want to add a new application or a new device, or change the settings, or add a new user, the home OS supports this as well. Yeah, the actual implementation, home OS is written in C# using the .NET 4.5 framework. It's been updated, but at this point it's at the .NET 4.5 framework. It supports loading and unloading of modules. Of course, if we want to add a device or add an application, then we have to load those specific modules. And it also isolates the modules. It helps a lot to keep them quite separated using a sandbox mechanism. So it keeps resource constraints, so not every device can use every resource. And it kind of helps with security issues too. We don't want the backdoor to be opening at any time, any moment. And there are already some drivers developed off the shelf. You can find this online on the Home OS store. So for Z-Wave lighting controls, for door sensors, smartphones, there's a bunch of drivers already out there. And just to show here that kind of how Home OS helps a lot the user when develop applications, because it derives already module classes. So
most drivers are already written, so the user doesn't have to be dealing directly through Z-Way. It just needs, oh, I want to use the camera and I want to use this function of the camera. Okay, and so hopefully if you're interested in HomeOS by now, it's very simple. You can just go to labofthings.coplex.com. You can download the source code from there. Just make sure you have Visual Studio and the .NET framework on which it runs. Once you have that, you just build the core solution and you're ready to go. You can, it has already an executable startplatform.bat that you can run, and it'll open a dashboard. Well, you can open it on the browser. And from here, you can just start adding applications, detecting devices, etc. And here I just show from the website, there's a lot of applications already online that you can use, and this is a sensor application, and drivers too that you can use. So it's cool that you can actually upload them or download, because since of that abstraction layer, you're able to use drivers that other people have developed, or you're able to use applications that other people have developed. And some examples of people have done, so I just mentioned two of them. So for example, program Home to take actions. So when one device does something, then another device does something. In that example, when the thermostat, which is one of the devices in HomeOS, is set to 65 degrees, then turn off the fan. So these two devices communicate with HomeOS, and it allows it, if it's too cold, then just turn off the fan. And also a mobile energy monitor. So this smartphone is connected directly to the monitor, and then through HomeOS it will just send a message explaining periodically like how the energy usage has been for a period of time. Okay, so this is not specifically a live demo because I had some issues with the libraries. So just be careful when you download them, because you gotta make sure you have all the operating systems and libraries. So it's a bit buggy, but I still think the UI is very nice, as I'll show now. So say we want to install a sensor on the door, see how often you come in and out. So this is the dashboard I talked about before after you build it on Visual Studio. Say you add your ID, your password, so it knows who the user you are, so you can set the preferences you want. And then this is the main dashboard. So let's say we add the device, add the sensor that's on the door. It already supports here, if you want to add any Z-Way device, it'll discover them. And then it'll be discovered, you pair it. And then if you write any applications, then you can install those applications that use that sensor. So here, for example, is the code of that sensor. This one you can find it online. But you can write any application of your own. So now the sensor application will appear there. And once we click on it, it'll start, well, depending whatever the application does, but this one, it'll output whenever the door is open or closed, change from 0 to 255. And there's many devices that are already supported by drivers. So like the Kinect or the smart camera, these are already supported, but if you want to add another driver for a different device, that's also completely possible. And some references, there's a very interesting paper on this by Microsoft Research, because this was all developed by Microsoft, and they're being used in a couple of, like, I think 20 homes right now for still testing purposes. And also a lot of special things to Cheng Wang, who really helped me a bit developing the code. Yeah, that's it.
Yeah, so as you mentioned, this is Microsoft thing, and this Lab of Things is kind of Microsoft's take at Internet of Things, and they're kind of pushing it quite a bit also at the research community. And so in any case, I mean, it's stuff that you can download and give it. Okay, so we'll meet after Thanksgiving. Have a great Thanksgiving.